Hi everyone, welcome to the Postgres Google Hangout. Today we are going to talk about tackling scalability issues with table partitioning in PostgreSQL. And this session will be run by Samir Kumar, who is a database solution architect. This Google Hangout has been brought to you by Ashnik. We are an enterprise open source solutions company based in Singapore with presence in Southeast Asia, UK, US, and India. We offer PostgreSQL solutions and services across these regions, and we're also the master partner of EnterpriseDB for Southeast Asia region. So let's begin today's session. Over to you, Samir.
Hello everyone, hi. In this session we're going to bring to you table partitioning and how to do table partitioning and what are the caveats and what are the limitations of table partitioning in PostgreSQL and how effectively you can implement that for your particular environment. But before we start, I would do a quick recap that in a previous Hangout we concluded our series on streaming replication. We have done 3 Hangout videos on streaming replication, and if that is something that interests you and you're looking for and you're looking to learn how to set up streaming replications, setups, and what new changes have been there in streaming replication in version 9.3, or what are the upcoming features in streaming replication in version 9.4, you can go and check out our videos, previous videos on YouTube, on our channel, which is youtube.com/ashnikbiz. Now, let me start with the Hangout for this session. Let me start with a presentation. So, before we get into how to do partitioning, let us first understand why do we need to do partitioning? Why at all do we need partitioning? Now, let's look at some practical examples of that. Have you ever browsed through a huge book, something like as thick as this? Have you ever tried doing that? You will be exhausted looking for the information that you're trying to fetch from this book. And there are good chances that it will take you a day or a half day of time before you can get to the exact information. Well, even if the book is well indexed, there are chances that the index itself would be quite thick, and you will spend enough amount of time, maybe a couple of hours, scanning through the index itself. So what do we do? Have you seen encyclopedias? They are as thick as the book that we saw on the slide, couple of slides before this, but they are well partitioned. They are broken down into multiple volumes, volume 1, 2, 3, 4, or volume A, B, C, D. And these volumes are broken down on an alphabetical order. There is a partition key, or there is a particular pattern of that whole phenomena of breaking down. That is how you can quickly pick up a particular book. Let's say if you are looking for Singapore, you will pick up the volume S, and in that volume you will have an index at the end of it. This index will be very thin, not as thick as the book itself, and then you can very quickly get to the result that you are looking for, isn't it? And that makes your life easier, that makes your search faster. There are a lot of other practical examples of partitioning from our daily life. For example, if you have seen journals are broken down into multiple volumes. These volumes are based on years or months. Same applies to newspapers as well. Newspapers are also archived. If you have gone to any websites or any digital edition of the newspapers, you will see that they are archived based on years or weeks or months. If you notice that whenever, this specifically happens when you are visiting any financial organization or when you are going to a government office or a bank, they will have an entry and exit record keeping system. If you are a visitor there, you will have to enter your name and other particulars, and then you will have to share the person name whom you are visiting and the purpose of visit. And these journals or these books are referred to whenever there is an inconsistency or there is an investigation going on. And these books are not a continuous history or a log book. these books are maintained based on months or weeks. Now, if I want to go and check who were the people who visited on 9th August 2012, I know that I need to pick up a book which is August 2012. That makes my search faster. So there are a lot of other practical examples of how we partition data in our day-to-day life. Now let's see how that concept is extended to relational databases. Pretty much the same thing, like whenever we have to deal with time series data or whenever we have to deal with huge number of records, we partition them. Or if we anticipate that the data volume can grow over a period of time, we partition them. Pretty much the same thing that we do with databases as well. What we see is if the number of records is too huge, or if the query is becoming slower as the data is growing, we think about partitioning the tables. In addition to that, if we think that the archiving or purging of data is going to be slower, the data that we don't need anymore, and we want to purge that data, and we fire a delete query for that. So let's say we fire a delete query, delete from a particular table where records are older than 31st of December 2012. So we are trying to delete all the data which was created in 2012 or before that. Now this delete command may take huge amount of time depending on the data volume. The reason is it will have to scan through all the records to match the record that we are looking for, all those records that we are looking for. Now, if you remember the example I gave on the previous slide, the bookkeeping system or the record keeping system at reception or the entries or entry gates, what people generally do with those record books is they simply pick up those books which were of August 2012 or September 2012 or December 2012. Those books are simply picked up and kept inside an archive, on an archive rack or inside a separate storage room which is for archival. It is as simple as that, because all the records at that particular month are in that particular book. Whereas if it is a continuous book, you first have to search for all the pages which are for that particular month or for that particular year and then tear them off. Whereas if they are in a particular book, you just move that book around. Same way, if you have got a particular partition for all the data of a particular year or a month, you just have to drop that table or just move that around. That makes your life simpler and easier in terms of archiving and purging as well. Now, this is how the table partitioning looks like in case of databases. You have got a single table. All your queries, all your database inquiries, all your database interactions will always deal with this single table called sales report. Whereas underlying that table, you will have three different physical tables. These three physical tables will have their own indexes. Now, let us look at some of the advantages of partitioning. Now, like I mentioned, each table has got its own index and they are partitioned by a particular partition key, which is your months or date. And whenever you are firing a query, let's say you're trying to find out all those sales report records which are generated on 21st of March 2014, then in that case, the query will be routed to a particular table. It will not go and scan through all the records. It will probably scan through only 1/3 of the records. If the distribution is even, it will scan through just 1/3 of the records. And the index is going to be very thin on that particular table, so it will be much more faster. So your query performance becomes fast if you are including the where clause, which is same as your partition key. You can quite easily purge or archive the data. So data which is older than certain or which falls in a particular quarter, if you want to move that around, you just have to drop that table and the index, or even if you just drop the table and say cascade, it will drop all the underlying objects as well. As simple as that, as easy as that. You don't have to write complex delete queries. You don't have to wait for those delete queries to complete. This is a DDL command which pretty much gets completed in few seconds or milliseconds. You can easily archive your tables, which means you want to remove certain records from your live table and move it to an archive table. Even in that case, you just have to detach the partition from your live table and attach it to the archive table. As simple as that. It is a single command or a few commands which will achieve this. Just have to say attach, or you have to say detach from the parent table and attach in the live table. That's all. As simple as that. All these are DDL commands. Again, all these are DDL commands. So makes your life easier, completes in few seconds. One great advantage of partitioning is tiering of data. You can tier your data according to the way you are accessing them. There will be some data which is rarely accessed. There will be some data which is relevant for you, which means that you are probably going to access it once in a day or once in a week. Then there will be some data which is hot for you, which means that you are going to use it every hour or for online inquiries. The data which is hot for you, which is accessed quite frequently, can be stored on SSD disk or flash disks. The data which is not that frequently accessed, but that data is relevant to you, that can be kept on SATA disks, high RPM SATA disks, so that you will get decent performance when you are trying to access them. The data which is very rarely accessed, like once in a month or once in a year, and you can wait for a few hours to get that data, it does not impact any of your SLAs. That data can be stored on very slow disks so that helps you invest in your storage cost quite wisely. You don't have to buy very fast disks for all the data that you have. You just have to buy it for the relevant data or for the hot data that you are accessing quite frequently. Now let us look at partitioning and how it is done in PostgreSQL. There are three popular partitioning techniques which people use. Range partition, where you partition based on the range. So you will say that 10 to 12 or 10 to 20, or you will say things like all the records which are falling between dates 1st January to 31st of March. That is range partition. Each partition will have a range defined. Then you can partition by list. When you partition by list, in that case, you will specify a list or a valid domain of values for each partition, in which you can say that all those records which belong to managers, or all those employee records where job role is salesman, that goes to a particular partition, or which are the job role is manager, that goes to another partition. So this way you can use list partitioning. Then there is hash partitions. These are quite useful when you do not have a natural candidate for partition key. You don't have a natural way of partitioning your data. In that case, and still your data size is quite huge, in those cases you use hash partition, where you define a partition key, and a hash of that partition key is used to distribute data evenly among table spaces, or evenly among the partitions. Now, in PostgreSQL, the partitioning is implemented using child tables. You will have a parent table, and that parent table can have multiple childs. All these child tables are considered as partitions of that table. On each of these tables, you will be defining check constraints. These check constraints will basically avoid any inconsistent data or overlapping of data. These check constraints also help the optimizer route the query to a particular partition. So when you define a check constraints, let's say there will be a partition which contains records between 1st of January to 31st of March. So your check constraint will be defined on the report date column, and report date column will be restricted to have records or values only from 1st Jan to 31st March. That is how you define check constraints, or that is the reason why you define check constraints, so that invalid data does not get inserted into a particular partition. These check constraints will also help the optimizer decide the execution plan. Then you need to define some triggers. These triggers will be defined on the parent table, and whenever parent table gets a new insert or update query, that query will be routed to a particular table, to the particular underlying child table, to be more precise. And that is the key or the most important component of your partitioning in PostgreSQL. These partitions in turn can also be main tables, so you can create sub partitions. You can have a partition based on quarters, and under each partition you can create partitions based on salesmans. So you have a main table called sales report. Sales report is partitioned based on years or quarters, and each period or each partition has got sub partitions which are defined based on salesman or salesman ID. So you can and your query router or your query optimizer will be smart enough to guess which partition and which sub partition needs to be queried, and each partitions as well as each sub partition can have their own indexes. So this is an example. You create a main table, and we are going to share these slides on SlideShare. You can pick up all these examples and try it out yourself, and it should work fine for you. If you face any issues, you can raise a query as a comment on our video, or you can write to us. You can create the main table, then you can create some child tables. These child tables are going to be partitions, and hence we also need to define check constraints. So you see in red we have highlighted the check constraints. The check constraints are highlighted in red. So the first partition can have values for job as manager or president. The second partition can have value salesman. The third partition can have value as clerk. Now let us see. Now you need to define a trigger function. In PostgreSQL, triggers are defined using trigger function and triggers. So we are defining a trigger function. The trigger function essentially does the job of routing the data. Whenever you are getting a new value or a new row, the job for that row will be evaluated. And if it is in manager or president, it is going to insert it in the first partition. If it is salesman, send it to the second partition. If it is clerk, send it to the third partition. And then return null, which means that the parent entry or the parent insert will not go through. Return null from partition functions mean that you're not returning anything to the inserting or the calling table. The table on which triggered this trigger function will not get any data inserted, because the data is getting inserted on the child tables. Now you define a trigger, and that trigger is called before insert, because you cannot stop the insert on parent table after it has been inserted. That is why trigger has to be a before insert trigger. So we define a before insert for each row. If you are doing a bulk insert, or if you are using a select statement to insert data, for each row the trigger function should get fired. That is why we have defined for each row, and we are calling the partition function that we created earlier, partition emp. This is, if you see on the previous slide, This is the function that we have created. Now let us look at how the queries will behave on this particular table. So we fire an explain analyze for select star from employees, and we are defining job equal to salesman. If you notice, we have partitioned the tables. Let me take you back a few slides back. So if you notice, the check constraint and everything has been defined on the job column. So job is our partition key here. So the moment you fire a query which has job in the where clause, the optimizer will try to match the partitions which matches this criteria. It is something called partition exclusion. This process is called partition exclusion. Optimizer tries to leave or remove those partitions from the plan which does not satisfy or whose check constraints do not match this criteria. Based on that, the query plan will be generated and query will be executed. Now, if you look at the query plan, it tries to scan the employees table, which is parent table, but that the cost is 0. Since it has not got any rows, the cost is 0. Whereas there is another entry for sequential scan on employee sales. So it has got to the particular partition and it is trying to execute the query there. If you see, there is no other partition included in this query plan. Now let us look at some of the caveats or some of the limitations of partitioning implementation in PostgreSQL. At present, there is no way you can ensure that the check constraints do not overlap, which means the constraints that we define on salesman or the check constraints that we define for the clerk partition or the salesman partition or the other management partition, we cannot in any way ensure that they do not overlap. I could have defined the check constraint on salesman partition to allow values salesman as well as manager. In which case, if I fire a query on job equal to manager, it will go and scan two different partitions. And if you do this mistake while defining your partitions and you overlap multiple partitions, your whole query execution plan may not work out well, and you may not get any advantage from the partitioning. Now, if in addition to that, if you want to do any changes in the partitioning logic, or if you want to attach a new partition, or if you want to detach a partition, there will be significant amount of work involved in modifying the trigger function. You may have to go back and add new blocks of if conditions for new partitions, or remove if blocks which are belonging to the older partition. Or if you want to swap the partitions, again you will have to modify two different trigger functions, one for the live table and then for the archive table. Plus, if you want to split any partitions, if you want to split a partition, let's say the management partition, which is allowing two values right now, salesman and president, if you want to split them, that split needs to be done with quite a lot of amount of work. What you need to first do is you need to create a new table, you need to transfer data from the old table to new table, you need to delete the rows from old partition or the old child table, and then you need to attach this new table as a partition on your parent table. After that, you need to also go and modify the trigger function, and you need to remove the condition, or you need to modify the condition which includes management, manager and president. So let's go back to that. You will have to modify this section. You will have to modify the first if condition, and you have to remove president from there and add another if condition which includes president. This is quite a lot of work, and if you are doing partition splits quite frequently, this could be very tedious. Other than that, if you, it fairly complicates your whole setup if you have got insert triggers on your tables. If you have got any after insert tables on the parent, after insert triggers on the parent table, you will have to modify them, or you will have to create the same triggers for each child table or each partition that you are creating. So these are some caveats which you need to be sure, you need to be very cautious about. You need to be careful about them when you are implementing partitioning in your environment. Now let us look at some of the advanced features of EDB Postgres Plus from EnterpriseDB. Out of all the features that EnterpriseDB provides in their Enterprise Edition, partitioning is probably one of my favorites, and you will see the reason why in upcoming few slides. One reason is the simplicity of syntax that I can use. So I can say something as simple as 4 lines of code to do what we did with code which was spanning across 4 different slides. Now it is as simple as saying partition by range, and then I just do partitioning based on that range. That's all. I define the rules for each partition, and that's all. I don't have to create any specific triggers, or I don't have to specify any kind of check constraints. I just specify the partitioning key and partitioning rule. That's all. I can create list partition. The example that we went through on the previous slides can be implemented in Postgres Plus in just a single create table statement. As simple as that. You do not have to worry about creating the trigger functions, or you don't have to worry about creating the creating the trigger, or you don't have to worry about the check constraints or overlapping of check constraints. So this is as simple as that. Now if you want to play around with partitions, what we saw as caveats in PostgreSQL section, it becomes quite easy in case of EnterpriseDB. PostgreSQL is also capable of doing all that. It is only the ease of syntax that EnterpriseDB provides, and that makes a DBA's life fairly very easy. If you want to add a new partition, that's all. You see the first command, alter table, add partition. That's all. If you want to split a partition, you just have to say alter table, split partition, and the partition names. That's all. If you want to update the partition key, let's say you want to update or move a particular person who was who was a manager, and you want to move him from management to president role, that becomes fairly easy in case of Postgres Plus. You don't have to worry about writing extra triggers which handles these kind of updates. If you want to swap partitions, it is again quite easy. Just have to add a partition on your archive table and exchange that partition with your live table. That's all. And you can also quite easily do sub-partitioning in Postgres Plus. You just have to say partition by a particular column and sub-partition by another column. Remember that your partitioning technique and sub-partitioning technique could be different. You can use range partition for partitioning and list partition for sub-partitioning, or other way around. Or you can use same method for both of them. It does not make any, it does not add any challenges at that point. It is fairly simple to do any of these things. As you see, we have created partitions based on year, and each partition has got sub-partition based on countries. Now the same thing can be done in PostgreSQL as well. Only thing, you will have to write multiple trigger functions for each of the partition, because each partition is going to have sub-partitions. So you are going to have to write multiple functions. You can have some kind of automation in that based on names and partition values, but still management and maintenance of these functions can be tedious sometimes. Whereas here it is quite simple, quite straightforward, and the syntax is quite intuitive as well. Now let's look at what is coming up in the next version. So far, hash partitioning is not there in Postgres Plus, but that is soon going to change as soon as version 9.4 comes out. Version 9.4 is going to introduce hash partitioning. Our team has been actively trying it out, and we have been quite excited with the results. We have been quite excited to see how we can distribute data even if we don't have any natural partitioning key or any obvious method of partitioning our data. In those cases, we can do that hash partitioning, and we are quite excited about it at the moment. And if you look at the syntax, it is as same as the syntax that we saw on the previous slides. Only thing here, you are not providing any partitioning rule. You are only providing the partitioning key, and that's all. You are not providing partitioning rule because there is no rule. The data will be evenly distributed. This is quite helpful when you are getting huge amount of data and huge amount of write requests. You can distribute them among different table spaces, and your data can be distributed among different table spaces based on some natural key, which could be something like account ID or transaction ID or patient ID. So if you're writing 100 records, 20 of these records can go to each of the 5 partitions. Now, there are certain limitations at the moment with the way partitioning is implemented and done in EnterpriseDB, Postgres Plus, and PostgreSQL. But we are pretty sure that the community is working on all these aspects. Things like partition pruning or exclusion happens only if the where clause is included in the partitioning. At the moment, there is this is something which is not possible, and I believe this is something which is practically not possible. The reason is, if you do not specify the partitioning key in where clause, there is no way one can know which partitions have relevant data. You cannot simply rely on the statistics, and that is why this is something which is not possible at all. Whereas other two limitations, things like global indexes, an index which can be created on the table or the parent table and which spans all the partitions or the child tables. That kind of index could be quite useful on certain instances, which is something which is missing at the moment, but I'm pretty sure community is working on those things. EnterpriseDB is also actively taking it up. If there is a huge demand for this kind of feature, I'm sure we will see it one of the next releases. At the moment, your optimizer cannot access all partitions in parallel, which means that if your plan or your execution plan has to fetch data from 3 of your partitions, there is no way optimizer can do that in parallel. It all happens, it all happens one after other. So the parallelism is in PostgreSQL is something which is being actively worked upon. We know that there are PostgreSQL developers and there are active threads where these kind of things are being discussed, and we look forward to having this feature in Postgres in near future. Now, if you have any suggestions or any queries, if you have suggestions for topics, we are listening to you. You can send your queries to us. You can send your suggestions to us. We recently received a suggestion from one of our viewers who was requesting to take up parameter tuning in our upcoming webinars or upcoming hangouts, and we are surely going to do that. We have taken that feedback, we have taken made a note of that, and probably next or a hangout after that, we are going to discuss on parameter tuning. So stay tuned. It's great to get feedbacks. It's great to get questions and suggestions and criticism from you guys. It keeps us happy to know that people are listening, people are learning. It is useful to you guys. Keep writing to us. Thanks a lot. Over to you, Deepthi.
Well, that's all. There is a Q&A app. If you all have questions to ask, or you can just add it to the group chat, or just put it on the YouTube link that we have, and we'll get back to you with the answers. Thank you so much.
Thanks a lot.